Hello, welcome to this week's edition of Recording Something Over and Over Again. Well, trying to. This is my third time doing this video, but the first time I didn't share my screen right. The second time I didn't record it. Okay, I'm recording and I'm sharing my screen. Everything's going here. All right, I'm going to do some notes. My enthusiasm is going to have suffered a little bit. Didn't get to see the other videos. But anyways, I am happy to be here. I'm happy to teach you. It's frustrating to do something three times, but you will probably learn something about that in math class because you have to do the same problem over and over. Okay, so want to talk about notes. We'll talk about percentages. That's the main kind of thrust of module one. It's a fairly small workbook. Remember, you got workbook discussion and Knewton. Knewton is the online thing. I'll show you that in a minute. So the way I like to do things is I like to do a little bit of notes, just to kind of give you the concepts, give you some important equations. Let me make a quick plug about notes. It's important that you take notes. You know, I can't tell you how to live your life or how to do class, but I will say it's important to have things written down somewhere. It's very helpful for your workbooks, for your projects, for the Knewton work that you're going to be doing. So I do recommend writing things down somewhere. This is not a lot to write down. You do want it to be in a place where you can refer to it and find it easily. I really like the little percent triangle thing. I'm going to show you how to use that as we go through some of these problems. But basically, a percentage is just a part to whole ratio. So I put the part over the whole, and I've got myself a percentage. There are some different ways that you can format percentages, and there are some problems in Knewton about converting between decimals and fractions and percentage format, and Excel has something to contribute there. Okay, let's just jump into some problems here. First of all these problems I try to ground in real situations so that they don't seem fake. They do have contexts. It does force you to read and process words. So that presents kind of an additional challenge to people who are English language learners. But there's a lot of support here. And of course, you know, there's tons of tools online where you can take things and put it into your own language so you can see it easier if that's an issue for you. But reading is just a very important skill in terms of like reading things carefully, looking at what you're supposed to be doing. So we'll make a plug for that. All right. So we got a nicotine pen, says it's good for 2,700 puffs. The content says it's down to 15%. And the question is how many puffs are left? And so showing you how to use this little triangle situation, what we have here is a situation where we're interested in finding the part, but we know the whole 2,700 and we know the percentage 15%. So the way the triangle works is if I want to know the part, I cover that P up, and then what's left is W and percent. Now they're next to each other, and in math, when you put things next to each other, it means multiply. And that is written out here for you as an alternate form of this equation down here. But one of the things I like about the triangle is that it takes away this sort of algebraic load of like, well, you got to move things around. Maybe you're good at that. Maybe you haven't done algebra in a long time, or you never were friends with algebra. So I just like to present an alternate way of thinking about that. So what I need to do is I need to just multiply the percent. What is 15% of 2,700? So this is sort of an interpretation of the question. Really, I just need to do 15% times 2,700. And then the question becomes, how do I do it? So you may feel inclined to pull out your calculator, your phone, use your phone calculator. One of the things we do in this class is we use Excel as our calculator and our notebook and where we write things down. So I'm just going to do it here for you, 15% times 2,700. And notice a couple of things. First of all, times is not the X symbol, it's the asterisk. Asterisk is shift 8. And then there's an equal sign in front. And the equal sign is really important because if I don't put the equal sign, then nothing happens. And so to tell Excel, like I'm trying to use you as a calculator, I put the equal sign in the front. Now, the 15% can be written in a bunch of different ways. It could be 0.15 times 2,700. And I could also write it as a fraction, 15 over 100, because that's literally what percent means. It's out of 100, 15 out of 100. Both give me the same answers. 405 is what I would expect to get here. Okay. Second question is, a person has 28 tables to clean in their job as a busser. They've already done 10. What percentage have they done? So this type of thing comes up a lot as I think about, I'm in an exercise class and it's hard and I'm like, oh, how close to the end am I? If I go back to my little triangle, again, I'm thinking, all right, well, I know the part and the whole, but I'm being asked to find the percentage. What percentage have I done? And so I'm going to cover this up. And I see that I just take P divided by W. Yeah, that's the original definition of this. And so I'll take the part, I'll divide it by the whole, and that should give me my ratio that I'm looking for. So equals 10 divided by 28. Now, by the way, if you just forgot the equal sign, you said 10 divided by 28, it's a little annoying because Excel could interpret that as a date. And then you're really up a creek because if I switch it back over, I'm like, oh no, I meant 10 divided equals 10. It's like a zero. Oh God, what's happening? So Excel can be annoying. I will tell you that, as in part of that is just getting used to how it works and the fact that there's formatting for cells and that Excel sometimes will switch it. It'll try to interpret what you're doing and it'll do things that you don't understand. Again, ask questions. If something's happening that's weird. That's one of the nice things about being in class and doing this is that you have, you can look at the person next to you. You can bring in a specialist, ask me to come over and look at something, and usually we can figure it out pretty quickly. One of the things that this question brings up, though, is rounding. And so I want to quickly pop over to this sheet and look at some rounding here. So there were a few more decimals there. It was 3, 5, 7, 4, 2, 9. So I'll put in a few more decimals here. And just a quick note about rounding. It's important. It comes up a lot. And it comes up not because, in the case of Knewton, it will often say you need to round very specifically. But in the context of us doing work, especially as we get closer to the projects and in the projects, if we're talking about math, rounding is an important part of being able to do it. And it's because we don't want to have too much information given to us. What it does is it forces the person to start thinking about details that are not that important, and then they lose track of what's actually happening. So that's why we round. And I wanted to do a quick thing on rounding because maybe you haven't thought about it in a while. So that looking to the right of the decimal place, so you have the decimal, and the next number is called the tenths, then the hundredths, then the thousandths, and there are more after that, the 10,000s, the 100,000s. I'm going to stop here because typically when you're asked to round, you're not going to go farther than this. So let's say we've been asked to round to the hundreds. So my technique is to underline the hundredths place, and that's the 5. Okay. Then I'm going to cross off everything else. So I just put a line through it. I don't need that stuff because I'm rounding to the hundredths, which means everything else is going to get tossed out. But before I toss it out, I'm going to look at this number and make a decision. So do I stay at 0.35 or do I round up to 0.36? So I sort of think about it as 35 versus 36, but it's actually 0.35 and 0.36. So the 7 is on the high side of things. It means we're going to round up. So the rounded version, if we go to the hundredths place, would be 0.36. Now, what's cool is Excel actually has a tool for that, like many things. And so if I'm looking at this number and I want to round it, I can use this button here. And again, this is, if you're using Google Sheets, it's just not going to match perfectly. If you're using a different version of Excel, maybe you're on the web version, it might be in a different place, but the tool is there. You just got to find it. So you can actually say, hey, just round this and then go back to the hundredths place. So that's pretty cool. All right, I'm going to delete that. And then I'm going to go back here because we're not actually done with this question. The question was what percentage. I just did the math to divide. To make a decimal into a percentage, I put the little notes down here. You either multiply it by 100 or you format it as a percentage. So I could go into this problem and just say times 100, and then this would be my percentage. Again, now you really are into a rounding situation, but I could just use this tool and say, okay, I don't need all of it. The other option is that I can just format this as a percentage. And that's probably what I would do if I were doing this problem, because I know that there's a percentage button here. So if I just click on this button, it turns it into a percentage and it rounds it for me. So that's nice. Notice that it rounds it to a whole percentage. There are extra decimals back there. Again, that's what this other button is for. If I want to see more decimals, I can. So 36% is an approximation of what percentage done I am on this job. Okay. Let me just pause and make sure there's nothing I want to say more about that. I feel like I'm speeding through, but I have done this 3 times. So it is what it is. All right. Last question. There's another one, but I'm going to do some more notes before we get to that. A person's finished 12 problems and the progress bar says that 30% done. So how many problems are there total? So in this situation, which I hope again feels familiar, you've done some problems, you've got a progress bar, so you can see, oh, I'm 30% of the way. How many problems are there total? I'm going to go back to my notes. I'm going to cover up the part that I am looking for. What I'm looking for is I'm looking for the whole. I know the part, I know the percentage. So it turns out I need to take the part divided by the percentage. So this is kind of a weird one because, and this is really why I think the triangle is important, because if you are not good at algebra and you try to like manipulate that, you might, get things messed up. It doesn't really make intuitive sense why I would take the part and divide it by the percentage. I could try to explain why that makes sense. But if I go back here and take a look at this, let's just see what happens. So I take the part, 12, and I divide it by the percentage, 30%. And there we go, 40. All right, now let's validate. Let's think about whether that makes sense. First of all, is 40 reasonable? Yeah, 12 is part way. I need to do more problems. This number, the total number should be bigger than 12. A little higher level of validation, 50% of 40 is easy. That's 20, it's half. And so I'm not there yet. So 12 problems could be 30% because 20 problems would be 50%. Okay. I think validation is an underappreciated skill. I mean, a lot of times students just get so caught up in like, I just want to do this and be done with it, that they don't have the energy to look at the validation. But if you think about real life problem solving, validation is a huge part of it. So if you want to be good at it, it's good to apply it and practice it and think about it. I mean, that's part of what college is about, right? Practicing real life skills that help you get better at thinking. All right, so we're done with these basic 3 problems. I want to look at the next note sheet here. I just pointing out the whole equals the part divided by percent. So the only other formula that shows up in, and we'll do a lot of applications in workbook 1, but the only other percent formula that you need is percent change or percent difference. And I wrote 3 different versions of this. You can write all 3 of these down. The point is that the way that people think about percent difference may change slightly based on, whether there's a chronology in it or the type of thing that we're looking at. But they all have the same structure, which is that there's a difference, subtraction on top, and some kind of ratio. That's the making of the percentage. And then the times 100% is really just the formatting to turn it into a percentage. So let's look at a problem based on eggs. Eggs have been a very interesting reminder of inflation and the fact that rising prices are still a problem. So if eggs were $4 and now they're $9, and I don't actually know what the real numbers are because I'm always just trying to shop for the cheapest. Well, but are they cage free? Oh my God, it's complicated. All right. So anyways, the price of eggs was 4, now it's 9. What's the percent change? So there is a chronology implied here and a sort of nice little mechanism to scaffold these problems is you have the old and you're going to the new. Okay, so you have the old and you're going to the new. So then the subtraction is new minus old, and we're going to divide by old. And the one that I'm sort of modeling here, but I'm using different words, is ending amount, starting amount, starting amount. So we started at 4, we ended at 9. So that's the new minus old. So when there's chronology involved, new minus old divided by old is kind of a nice shortcut to get there. But again, it's not important that you remember it. You should have that stuff written down. So you should pause the video, write down the different versions of it, and then we can come back and do this problem. So, and in fact, you should try to do this problem before I do, just to see if you get the same answer. So this is one of the great things about videos, is you get to pause and try stuff. All right, 9 minus 4 is the new minus the old value. That's a change of 5. And then I'm taking 5 and I'm dividing by 4, and I got 1.25. Now, it's very important here that 1.25 is not a percentage. It's the decimal format of the percentage. So I need to either multiply by 100, which is what the formula says, times 100%, or format as a percentage. So I'm just going to do formatting as a percentage because, again, that's what I prefer. So 125%. Now, I brought this example up just to remind you that although it is true in general that percentages should be somewhere between 0 and 100%, we do have situations where we get values that are over 100%. That happens. You can have negative percentage values. That can happen too. So don't get locked into like, oh, no, it's greater than 100%. That's weird. Yeah, that happens sometimes, especially in these percent change situations. Okay. So I think that's all of the notes that I have for you around percentages. I do want to do a quick lesson on the multiplier concept, and then I'll probably just stop this video because I tried to make it 3 times and feel like I'm on a roll and I should do it and get it posted. It'd be good. And then I am going to show you some things about Newton and yeah, maybe just problem solving in general. All right. So the multiplier concept is a nice way to apply percentages that are increases or decreases. And so in workbook 1, what you'll see is you'll see discounts and tipping and things like that, where we're taking an original amount and then we're either reducing that amount with a discount or we're increasing it with a tax or a tip. And so we can just do that problem as, well, I'll find the percentage. We know how to find a percentage. We multiply multiply the whole by the percentage. And then I can add or subtract from where I started. But the multiplier concept can be really helpful, especially when you're trying to like chain a bunch of these things together. So if I have, say, a 10% increase, maybe your tax is 10%. That's actually pretty close to what the sales tax is in Chicago. What I do with the multiplier concept is 3 steps. First off, I'm going to start with 100%. Secondly, I'm going to add or subtract, and that's increase or decrease. So add, increase, subtract, decrease the percentage from 100%. So I'm adding it, I guess that would be to or from, right? Adding it to, subtracting from. I just, start with 100%. 100% comes first, then you're adding your percentage or you're subtracting your percentage. And then finally, you're going to multiply. And that will end with you having the increased or decreased amount. So it's really just 3 steps. Start with 100%, add or subtract, multiply. And so with a 10% increase, I do 100% plus 10%. I'll do the math here, 100% plus 10%, 110%. And now that's my multiplier. So if I multiply whatever by 110%, that will give me a 10% increase. And so if I take something like, I bought something I just bought some Apple AirTags for $99. So I have to pay tax on it. Let's say the tax is 10%. I could find 10% and then add it on. Let me show you. 10% of 99, that's equals 10% times 99 And then I'm adding that on 99 plus 990. There's nothing wrong with this approach. But I could have just, I know the multiplier is 110%. I could have just said, oh, I'm going to take 99 times 110%, and I get there in one step. Really, I get there in two steps because I needed to make the multiplier, and that had its own process, and then I multiplied. This is really useful in a lot of situations, and it's absolutely necessary in one particular type of problem. And let me show you which one that is. So it's this, it's these examples here. If you're trying to find an original price, the discount has already happened or the extra fee has already happened. You have to do this multiplier, and the multiplier is written out in the denominator, the bottom of these two examples. But if you know how to do the multiplier, you just find the multiplier, and that's what you divide the new price by. If you don't do it that way, you actually end up with the wrong answer. And I can spend more time talking about why that is if you're interested. But so the multiplier process, I think, is both a useful tool strategy to kind of shorten up the work that you're doing, but also absolutely necessary in a very specific type of problem. Okay, I'm going to pause there. Okay, so what I decided to do was to just get Knewton in here and kind of show you a little bit about how Knewton works, just because I've had these failed recordings and I need to move on with my day. But if you need anything more, if I went too fast, just send me a text and say, hey, do more videos on this. I'm happy to make videos. It's a really useful thing. I have a whole YouTube collection of videos that you can search and that future students can see. So it's like I'm providing something that I know will be useful to other students. So I'm really happy to do that. This is not the way Knewton looks. If I'm just looking at the kind of overall structure here. When you go into Knewton, you'll see the link in the module 1 content, and you'll click on the button and it'll open it up and you'll start doing questions. But these are the sort of general topics for module 1. So percents with income taxes, percents and converting percentages, doing estimation, calculating change. That's the percentage increase or decrease with that formula, with the subtraction that I showed you. And then CPI and inflation, super relevant because inflation is a big topic that everybody's concerned about. So I'm just going to hit start on something here, and then we'll kind of just see a little bit about the kinds of things you're going to be facing. Okay. So convert 600% to a decimal. So first thing, if you've never used Knewton before, you get 2 chances to get this right. Okay, so if I put in the answer 3 and I press submit, it says, no, that's not right. Just try again. So the first time it just gives me the feedback. If it's right, great, you're going to move on. If it's wrong, it'll just say wrong. You're going to try again. So I'm going to actually do some work here. So if I want to make 600% into a decimal percentage fraction, there are 3 different ways that I could represent that. Right now, I've been given the percentage version because the percent sign is in there. So that's the percentage. So a way to think about it is I generally go through the fraction because what the percent sign means is literally over 100. So this is equals 600 over 100. And so the answer is actually 6. Now, it's not showing that because when you reduce 600 divided by 100, it would reduce all the way down to 6 over 1, which is just 6. So the decimal and the fraction are almost identical here. It's asking for the decimal, so I'm going to bring this back and say, oh, no, sorry, the answer is not 3, it's 6. And then I get, yay, I got it right. Now let's do another one. This time I'm going to get the answer wrong. So convert the percent to a decimal. I don't know how to do it. 3. And then I'll try again. Well, maybe it's 2. Okay, so the second time I get it wrong, I get an explanation. This is very important because if you feel like you don't know what you're doing, you have really literally no idea, there is instruction here for you. And so you can get instruction on how to do it. It's showing you that when you want to convert 50% into a decimal, really you just need to do 50 divided by 100. And again, that's because the percent sign means literally divided by 100. When I don't remember when I actually understood this, but it was a long time into teaching. And then I was thinking about this symbol and I was like, oh, there's the division sign. That's division. And you got the 2 zeros to represent the 100. I don't actually know what the history of the percent symbol is, but this is sort of how I understand what that means. Okay. So a lot of value in Knewton is in the sort of immediate feedback aspect. And so it's, just make sure you set time aside for this. It's not something you're just going to knock out in 30 minutes. I mean, if you do knock it out in 30 minutes, that's amazing. But for most people, it takes a little longer. There's reading problems, there's rounding problems, there's things that, you just kind of mess up on or you type it in wrong. So it's about patience, attention to detail, and making sure that you're understanding the concepts here. So you got some rounding problems. We talked about rounding to the hundredth, so you should be able to do that. And if you read it carefully, it says round each value to the hundredth, and then total is a keyword that means add everything up. So it doesn't say add, but you're supposed to interpret, oh, I want the total, so I need to add it up. So I'm adding, but after I round each one to the hundredth, right? And so I'll show you how I would do this in Excel. And so I would take the first number, which is 56.213, and I would take 7.983, and I would take 0.344. I'm going to do my rounding here, 56.21, 7.98, 0.34, and now I can add these up, 56.21 plus 7.98 plus 0.34. If you've used Excel before, you know that I could be using cell references. Not doing that in week 1. We're going to get into that in week 2. Just got to kind of take baby steps to get into this. And by the way, there is a Excel basics workshop next Monday. I think it'll be recorded, but it's a useful thing to keep in mind if you're feeling really overwhelmed by Excel. So I'm going to put in the answer 64.53, and we'll see if. Yeah, I got it right. Okay. So that's my plug for Knewton. With this video and with the workbook walkthrough, I think you're going to have enough to be able to do the work for the week. I'm going to go back and review things tomorrow and make sure, yeah, you've got everything you need. But if you run into something that you want more information about, what are you going to do? Well, I hope you said, I'm going to send him a message. And remember that texting me is a faster way to get a response than emailing me. 765. Oh boy. 3355867. It's in my announcements. I put it in the important info doc. So anyways, good to see you. Well, I didn't see you. You got to see me. Really sorry we didn't get to start this week in class, but we'll make it work. Please make sure you do something before you come into week 2. It's not a vacation the whole week. All right. See ya.